So I continue with my favorite calculus probability integration problem ever. The step one, if you look back at the last video, step one, we're going to find the volume of our, like we want the volume of this spot right here, but we're going to find the volume of, if we extended this up to here, we're going to find the volume of that whole thing. Well, how are we going to do that? We're going to do that with calculus, and remember, any integral, we're going to break an area up into tiny pieces, and we're going to sum them up. And what do we have here? We have, if we just, here's the sort of the visual. So each one of these squares on this AC plane has area dA. It's dA by dC. And I know this, so here's one little square. I know this is sort of stepping back maybe in calculus from what you know, but it's still, you know, still fun for me. So each one of these squares has got dA, dC, and what's the height of each one of these? Each one of these, let's do dark green. What's the height? Each one of these columns, or not columns. Yeah, I guess this is, each one of these is a column. What's the height of that column? Well, if you told me what A and C were, I would just say that the height of that column is, well, it's 2 root A root C, right? Because this this curve over the plane is this right here, is B is equal to 2 root A root C. Right? That's just from what we're interested in. Right? When we're interested in the discriminant. So one of these things right here. Let's do it over here. This one right here has got. I'm taking this out and blowing it up a little bit. We have dC by dA, and the height is 2 root A root C. And what are we're summing these up. So now we get to use our sigmas. We're summing these up from A goes from 0 to 1. C goes from 0 to 1. dA, dC. Well, okay. Let's make sure we have this right. We're summing up all of these columns. Well, let me rewrite the volume of that column. A goes from 0 to 1. Whoops. 0 to 1. C goes from 0 to 1. What's the area? What's the volume of that column? It's height times width times height times width times length, or these 3 dimensions multiplied together. It's 2 root A root C times dA dC. And let's take that interval. Like I said, this is a very straightforward way of doing it. Don't worry, it's going to get complicated. So that's equal to, so this is our volume. This is our V. Right, your V is the sum of our columns. So we have, let's first factor out this 2. We have 2 integral, and A and C are we can separate A and C. So this is the integral for A goes from 0 to 1, square root of A, dA. Integral from C goes from 0 to 1, square root of C, dC. Okay, so next, let's get rid of some of this. And so these are quite simple, well, fairly basic integrals to take. So this is 2, so this is A to the 1/2, right? So we're going to increase the power by 1, a to the 3/2, divided by the new power. So I'm going to put a 2/3 here. And that's going to be evaluated at 1, and then subtract evaluation at 0. And again, we're multiplying by. Did I put x there? I'm sorry. It's meant to be a to the 3/2. And same deal with c here. We have c to the 3/2 divided by 3/2, which is multiplying by 2/3, evaluated at 1, subtract 0, and you know, it should be very fast for calculus students. Evaluate at 1 and subtract evaluation at 0. Well, evaluation at 0 is just going to be 0, so we're really just evaluating at 1. This is 2 times 2/3 for the first, times 2/3 for the second. So what is that? That's 2 times 2 times 2, which is 8. So this is 8/9. And that is the volume of the first spot. Now, we still need to, the next step is going to be, and this step is a doozy, then the final is going to be to find the, so this is the volume of the big thing. We're going to still have to find the volume of that cap. And that's going to be the next, probably the next 2 or 3 videos.